Now I am here to discuss you about the science chapter is gravitation. This is chapter 3 in your annual syllabus. So, what is gravitation? If you throw anything, any object on the outside, then what happened? The object falls on the earth. Why it's this being happen? Because the earth is pulling the object towards itself. It means there is acting an attraction force between that object and earth. Means earth is pulling that object towards itself. So this is known as gravitation. This is known as gravity of earth. This is because gravitation of the earth. So there is a force acting between that object and between the earth. That's why the earth is pulling the object towards itself. This is the gravitation. Now, what are the laws of gravitation? Newton gave a law of gravitation. Now I am going to tell you about Newton's law of gravitation or law of gravitation. Simple, you can say this. Law of gravitation or Newton's law of gravitation. Law of gravitation or Newton's law of gravitation. Newton's law of gravitation. So, according to Newton's law of gravitation, the earth or in the universe, every object applies a force on any other object. Suppose we have taken example here like earth and any other particle. So in universal law of gravitation or Newton's law of gravitation, it tells that there is an attraction force between the two objects anywhere in the universe. So this attraction force is directly proportional to masses of that object and inversely proportional to the distance between them. Suppose we have two objects. Suppose we have two objects. Suppose this is A and this is B. And the mass of A is m1 and the mass of B is m2. Clear? And the distance between A and B is, suppose this is r. So according to universal law of gravitation, a force of attraction acting between them, and that force of attraction, suppose the force of attraction is F, is directly proportional to product of their masses. What are the product of their masses? M1 and M2. M1 and M2. This is first equation. And the other thing, the force acting between them, it varies inversely with their distance. Means this force is inversely their square. Square of the distance between them is inversely proportional. Means force is inversely proportional to square of distance between them. This is the relationship too. Now, what we have here? We combine these two equations, then what happens? F is directly proportional to m1 m2 upon r square. Now, if we remove this proportional sign, then what happens? We will put here equal sign and we have to put a constant. The constant is g, m1 m2 upon r square. So what is g? G is known as, what is g? Constant of proportionality. Constant of proportionality is known as constant of proportionality, or it is also known as G is equal to universal gravitational constant. It has a fixed value. Why it is universal gravitational constant? Because its value is fixed throughout the universe. And what is the value of G? It is 6.67 into 10 to power minus 11 kg in Newton per meter square, या न्यूटन इंटू मीटर स्क्वायर बोल सकते हैं इसको. ये जैसे 6.67 न्यूटन मीटर स्क्वायर अपॉन पर केजी, न्यूटन मीटर स्क्वायर केजी की पावर -2. So this is the universal law of gravitation. And what is the universal law of gravitation? Every object in the universe applies or there is an attraction force between the two objects in the universe, and this attraction force is directly proportional to their masses and inversely proportional to the square of distance between them. Suppose there are two objects M1 and A and B, and mass of A is M1, mass of B is M2, and they are separated by the distance R. So what is the force of attraction? It will be force directly proportional to product of their masses M1 into M2. This is the first relationship. And force is inversely proportional to square of the distance. Suppose this distance R, it's a square. It is inversely proportional to square of distance between them. Now combine these two equations. F is proportional to M1 M2 upon R square we get, and when we remove the proportional sign we have to put a constant. This is G. So what we get? F equal to G M1 M2 upon R square, where G is known as constant of proportionality, or it is also known as universal gravitational constant, and its value is fixed 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now if I say how this unit came, you can calculate this unit here. Now come here, and we have derived the formula for force of attraction in the terms of their masses. What are this? F is equal to G M1 M2 by R square. So what is F? F is we have to determine the unit of G. So if we can write here like F is equal to F into R square upon M1 into M2. So unit of G is F Newton, R SI unit meter square upon meter. Mass, this is mass, kg into kg, this will be kg square. So G, what is the unit of G is kg, Newton meter square upon kilogram square. Understand this? Okay. So now move to the next article. So now you have learned about the universal law of gravitation, and we also known about the unit of G. What is G? Capital G, universal law of gravitation. Now we are going to learn what is the importance of, what is its significance, importance of universal law of gravitation. So first. What is the first important? Okay, you know that in the universe there are various planets which have certain motion. So their motion is depend on the universal law of gravitation. So first one is motion of planets in their orbit. Motion of planets in their orbit. Second, what is second? Because this universal law of gravitation, every object binds with the earth. Suppose we are on the earth, we are bind with the earth. Okay, binding of. Second is binding of objects with earth surface. Okay. Now third is, I have told you in the starting of the chapter, when any object falls on the ground, when you throw the object upside, then it falls on the ground because of gravity. So rainfall, snowfall, this is because of universal law of gravitation. Because what universal law of gravitation says that every object in the universe attracts any other object towards itself, or there is a attraction force between the two objects in the universe. Okay, so moving further, what is Kepler's law? We are going to learn about Kepler's law. This is in your chapter. What is Kepler's law? As I told you that the motion of the object, motion of the planet is according to the universal law of gravitation. So what is Kepler's law? Kepler's law. Kepler gave three laws. This is related to the motion of the planets. How? Kepler gave three laws. He gave three laws related to motion of planet. Okay. First law Kepler, second law and third law. As you have learned about the motion, like here Newton's law of motion, first law, second law, third law. Here is also Kepler's law, first law, second law and third law. These have different names. What are their names? So we are going to discuss about the first law of Kepler or Kepler's first law. Kepler's first law. So, or this, what is its another name? Law of orbit. What is its name? Law of orbit. So Kepler's first law or law of orbit. What is law of orbit? Law of orbit says that each planet revolves around the sun in an elliptical orbit. In which orbit? Elliptical. The shape of the orbit is elliptical. You know that this is the ellipse, and each orbit. Suppose this is sun. Okay, this is the path of the planet revolving around the sun in elliptical orbit, and the sun at its one of the foci. Means if you have ellipse, suppose you have ellipse, then you have its two focus. Okay. Now in these two focus, sun is at one focus. Suppose this is one and this is the sun. So this is the law of orbit. What is law of orbit? Each planet revolves around the sun in an elliptical orbit with the sun at one of its 40. Means suppose this is sun and this is the elliptical orbit. Suppose there is any planet revolving in this path, okay, and the sun is at its 40. Understand? This is the law of orbit. Okay, this was the first law of orbit. Now we are going to discuss about the second law of orbit. What is second law? Second law of Kepler. It has another name. Kepler's second law. Kepler's second law, or law of aerial velocity. Aerial velocity. Law of aerial velocity. What this law says that suppose the object is any planet is moving in this orbit and this is the sun at one of its 40. Okay. It says that the line joining sun and the planet sweeps equal area in equal interval of time. Means suppose this is the planet, it starts its motion like this. Suppose after some time it reaches B. So line joining the planet and sun is this line. This is the radius r, in which radius is moving, and one line is this. So this area is equal to, suppose at any time the planet is here and after some time the planet is here and its sweeps is this area C and D, this area. It says that if the time is same T1 and T1, then the area of this area is equal to this area. Means aerial velocity will be same. Suppose the line joining between sun and planet sweeps out equal area in equal interval of time. Means if the planet is near the sun, suppose here, then it is moving fast, and if the planet is far around the sun, then it moving slow. Understand this? So this was the law of aerial velocity. Now come to the third law of Kepler. What it says? Kepler, and one more. This is the radius, and this is also we can say that R is the mean radius. Why we are taking here mean radius? Because R is changing, so we have to calculate its mean. We have to take here mean radius. Okay. What is the, now come to the third law of Kepler. Kepler's third law. Kepler's third law. Kepler's third law. And it is known as law of period. Law of period. And it is known as law of period. What it says that the square of the orbital period of planet. What is period? In how many times the object completes its one revolution is known as the period. The square of the orbital period means in orbit it when it completes how many times it completed its one revolution. The square of the orbital period of planet is proportional to the cube of mean distance from the sun. Cube of mean distance means this is r, I have told you. So suppose this orbital period is this, so square of orbital period is directly proportional to what? Mean distance or mean radius. This is the whole cube. So this is the Kepler's third law, which is known as law of period. Further you can write here like this. If you remove this constant of proportionality sign, then a constant came here. T, you can write here T square upon R cube. Okay. We will solve here many numerical from this formula. Okay. So this was your Kepler's law of period. Kepler's law of planetary motion, or you can say the Kepler's law of planetary motion, because he gave these laws on behalf of the planet's motion. Okay.